IPR policy by now, and only companies and people listed on the website are allowed to make substantive contributions. Welcome, everybody, to this interim. We're hoping to make progress on outstanding issues within WebRTC PC, and if time allows, I think we have one issue each in Media Capture Main and WebRTC Stats that we're hoping to get to, and as usual, we'll have editor's drafts that will follow the meeting. Stefan, you want to talk about going to CR?
Yeah, I can talk about that. As we have been announcing a few times now, we have the target to submit the request to transit to CR before the end of this month. So we need to deal with the open issues, at least the ones that we need to deal with and are not of editorial nature, and we hope this meeting will be fruitful. And I also want to remind about the thing I sent out on the list, I think last week, that we would like to get feedback from implementers on stuff they are not planning to implement. So we can highlight that in the CR. So, I mean, basically the idea is to get that in front of people's eyes, and if people are really interested in something that we see a risk for not getting implemented, they can start pushing implementers and browser vendors and so on.
Okay.
Stefan, I don't know where the right place to ask is, but I had a question it came up out of one of the PRs, but it's really about a generic question about this sort of at-risk process and marking that stuff. Is there a good point to talk about that sometime today for a couple minutes?
I think this would be the time.
So look, there's one of them that we had an API for turning on the RTCP MUX or MUX only, and there's a PR to mark it at risk. Now, look, that's fine. I don't have a question about, I don't care what we do with that particular API. But given that was a completely optional feature, it seemed to me, and it's very clear in the text, the browser is not required to implement it at all. It seemed to me that that's not something we have to worry about having two implementations at, and thus would not be one of the things that we should be going through and trying to be concerned about that. So is that correct? Or I'm not quite sure I understand which features we try and have two implementations of and which ones we don't, I guess is the question.
Dom, is this something you can provide input on?
Yeah, I mean, I guess at least features for which we expect no implementation, I think we should probably expect to remove from this version of the spec, because then we don't really know if what we described makes any sense until someone...
Well, I mean, the only reason we have that in the first place is we expected to use it in one of our internal things. Now, of course, why it doesn't matter to me is we can still continue to do that. It would just be an extension. But,
So, I mean, I think, since the feature is marked as optional, and if you have an internal implementation that can demonstrate implementation, I think that would probably be sufficient for keeping it in and, as an optional feature. So
you're saying the process then is if we have no, known implementations of something, even if it was totally optional, then we would remove it?
I mean, I think for something that is optional, there is quite a bit of leeway. I guess my personal perception is that if we don't, something that has found no implementation, it's more theory than spec, so we should at least look at it very carefully.
Yeah.
So, Tom, my understanding was, first of all, you don't have to remove anything for CR, right? And for something to be implemented, it doesn't have to be a complete browser, right? Could it just be that piece of whatever it is?
So that again, I guess, is also up to us to decide. Typically for a browser targeting API, and the title of the spec is real-time communications for browsers. I think you would expect to find implementations in widely deployed browsers as a first, at least as the main target. Again, here we're talking about an optional feature, so I think there is probably more leeway for negotiating among ourselves first and arguing about this with the director later. So that's part of the things we probably need to get consensus toward, basically.
So what I've heard claimed is that the requirement for implementations isn't a requirement on implementations, it's a requirement to ensure that the spec is actually comprehensible. So if two people understood it, then it's deemed comprehensible. And if nobody implements it, then we don't know if it's comprehensible or not.
Well, look, this is a question about W3C processes. The W3C process, we need one implementation or we need two? I mean, what's the story? Point me at what I'm supposed to be reading to understand what the process is.
Well, again, the process, so the first double implementation requirements is a should in the WCC process. And in practice, the working group set itself, I'll be sending you the various links if you want the details.
Okay, no, that's good to read.
But again, at the end of the day, the principle is mostly for the working group to decide what criteria it wants to use for going beyond CR, and then once these criteria have been decided, it gets presented to the director, and assuming the director approves them, then whenever these criteria are met, we can move to proposed recommendation. So I would say that the practice for, again, browsers-oriented API has been to demonstrate implementation in widely distributed browsers, just to make sure that working groups don't develop, APIs that would theoretically be nice, but that nobody cares about. But again, here we're talking about a specific optional part of an obviously fairly widely deployed API. So, I think there is lots of leeway for us to decide that, yes, it's okay if we only have it in a smaller deployment of browser type implementation.
I guess that probably then begs the broader question, in which sense it sounds like the process of what it does is largely something the working group writes and then proposes to the director. Probably we need to spend some time on that at some point. And once again, I don't care about this particular one in the slightest. It doesn't matter.
No, but I hear the same as you, Colin. We need, as a group, to decide what criteria we will use for optional and non-optional features before making the decision later on what to propose to the director.
Okay.
Yep.
So the link to the slides should be up on the wiki, although hopefully you can see them now. We are recording this meeting, correct? I think we're recording it. Yeah, okay.
Yes, we are.
All right. For discussion today, we have some WebRTC.
So, Bernard, at this stage, I think we need a scribe, actually.
Yeah, we do. Do we have one?
No.
Do we have a scribe?
Oh, this is
Can someone like Vivian at least take notes about what we decided? Or Peter, maybe?
I can do some of it, but in the middle of the meeting, I'm going to have some trouble. I have to move meeting rooms. So I can do the beginning and the end. I can't guarantee the middle.
But let us know when you have to switch rooms.
Okay.
Okay. So we have some WebRTC PC pull requests and issues, and also, if we have time, media capture and WebRTC stats with one PR each. All right, so let's talk about the WebRTC pull requests. The first one is network error, not defined and might not be needed. So network error is mentioned in potentially 3 places. There's section 6.2 relating to the RTC data channel where it's referred to twice. One is relating to when a transport's closed with an error. And the second one is when the data channel's underlying data transport can't be created, and then the network error is fired. It's not defined anywhere. In the event summary, it talks about the close event and an ordinary simple error event, and that's it. And then section 12, which is fairly recent, defines the RTC error, and it has some attributes like error detail, STB line number, etc., but it's not referenced anywhere in the spec. So we're trying to figure out what to do to clean this up. And so some questions for the group. First is when the RTC data channel transport's closed with an error, what event do you fire? And the second is when you have an error occurring in the data channel, say above the transport, what do you do? An example is if it's closed with an error, if there aren't enough stream IDs. So one of the things we've done, if you look in the issue bug, is people have been discussing a comparison to WebSockets. And in WebSockets, you have a simple error event, but a more complex close event where you have was clean, code, and reason attributes. Now, in WebRTC, we now have the RTC error event, which has multiple attributes, with a simple close event. So there's a contrast there between what we're doing in WebSockets and in WebRTC. And I'll talk about why I think that difference exists and see if people agree that we should maintain it or not. So a little bit about WebSockets, what it does. So they have a ready state as well, which transitions to closed if the WebSocket's closed. So you have the simple error event if the WebSocket connection is failed. And then on close, you have this close event with a was clean attribute as well as code and reason. Now, I believe that the reason WebSockets was designed this way is the client-server protocol, so that you have a code that might come back from the server and an associated reason. In contrast, the data channel is peer-to-peer, so you might have a code that might be delivered in the SCTP transport, but not necessarily above that. So that's what I think the reason for the design difference is. I don't know if anybody else wants to comment. So here's what we're proposing and what we're trying to rough out in the PR. So when the data channel transport's closed with an error, we're proposing to fire the new RTC error event, and we're creating an error detail enum value of SCTP failure, and also adding an attribute called the SCTP cause code, which is going to be taken from the SCTP cause code in the operational error. And then the message would be set to the SCTP cause specific information, possibly with additional text. And then when it occurs above the transport, the suggestion is to fire the RTC error event with an error detail of data channel-failure. Now, the alternative to that would be potentially putting a reason attribute in the close event, as opposed, possibly opposed to the RTC error, maybe in addition. I don't know if people have opinions, if there's any need for additional close event attributes. Today, we just have a very simple close event for the RTC data channel. Does anybody have an opinion on that? Or do people just think what's proposed here is okay? Or do you think it's horrible?
I mean, this is Randall Jessup. I mean, in general, the overall intent was for the data channels API to be approximately similar to WebSockets, not necessarily entirely identical, especially in the startup and shutdown parts. It's closer to the latter. But once you've created one, it should work roughly the same. So having the shutdown be the same or similar makes it easier to write code that could use WebSockets or data channel interchangeably. So there's a plus. The duck typing aspect.
Are you in favor of adding the attribute to the close event?
I don't know if that matters or not. I mean, what happens if we don't add it?
Well, then the alternative, I think, would just be to use the RTC error event with error detail.
Yeah.
But this is Adam speaking. When you write code that you want to use WebSockets and data channel, I guess even if we try to make it more like WebSockets, I think to make a app that behaves reasonably, you need to kind of prepare to handle errors for both kind of types of transport. Right. So I don't think someone can get away with just one error management function. I mean, I think you need to. So I don't know if we make them almost similar, perhaps that's a bigger problem than if we kind of make distinct separations of.
Yeah, I mean, the way I read
I'm almost in favor.
I kind of agree with Adam there. If you have to make an error handler, it can handle the two errors independently. I don't see, if there's an advantage to having them be the same, great. If there isn't, then let's leave them separate.
Yeah, I think the only difference, like it said, reading this, my sense is if you have a WebSocket failure, you would get the error event, and so you have to handle that in either case. I think the only difference would be in WebSockets you get a little bit more information on the close, and in particular whether it was a clean close or not, and whether if there's a code or a reason associated with that close. But I think you would know if it was an error related close, you would get the error event. So I don't know if anyone else has an opinion here, but I think you get more or less the same information with a simple close event in the case of the data channel.
Yeah, I think in WebSockets it's more like if you get the error event, you should investigate the close event more carefully. I think perhaps it's more, right, like having the errors in the error event, I think like proposed here is perhaps a bit more intuitive, but WebSockets.
Yeah, because they have in WebSockets you have a simple error event, so you'd have to go to the close event to get the reason, whereas we have a complex error event, so we can get it there.
Exactly.
Okay, so I think what I'm hearing is that the consensus is to keep the close event simple and use the RTC error for all the cases. Is that more or less correct? Okay. So
yeah.
Okay.
This is Taylor. I just wanted to point out quickly that RTC error itself is not an event type, so there need to be a separate event type that contains an RTC error.
Yeah, I think we just need to clean up Section 12 a little bit for that. Yeah, there's some other cleanup that needs to be done there. Okay.
Yeah, I think there will be an error event with this object as payload.
Right. Right. So basically, the on-error event handler for RTC data channel would need to deal with RTC error, I guess. Yeah. Okay. So this is the cause code cause specific errors relating for SCTP. So this is what we would put in there. And I guess it's up to you now, Taylor.
Right, so at the last interim, we discussed having a parameter to configure the packetization interval. There was discussion about also having the ability to query the capabilities, like see a list of supported packetization intervals, but we decided we're not going to do that because you only need the ability to provide a hint, and the browser might not necessarily use this value, but it'll use whatever is closest. So there you can see the content of the PR and the description there about using the duration if possible and otherwise using a closest available duration is the same logic that exists in JSEP for processing the A equals P time attribute in SDP. So basically, this will behave exactly like the attribute in SDP, but it allows the application to specify it on the sender side, and it will override, if there was a p time in the remote description, override that value. So I think it's relatively straightforward because it's just using the same logic as already existed. Isn't really introducing anything new, and it still will should cause a max p time if present to be respected.
And this will never set the negotiation needed flag, right? If you set it.
No,
Okay.
because this is sort of in addition to the SDP constraints. It's not directly modifying SDP constraints, though.
So, Randall, you had some opinion last time on this.
Yeah, I mean, I think the decision last time, if I remember correctly, was basically in line with my opinion, which was it should be, it should be the p time, and it should provide a preference for that. This seems reasonable to me, as I'm totally forgetting what I thought last time.
I think you said the same thing last time.
Yeah, looks good to me.
Taylor's calling here. I think this looks good too. I did wonder about closest, whether you maybe wanted the next larger one, but I mean, this looks pretty good.
I copied this from JSEP, so it's at least consistent with how JSEP currently says A equals P time should be processed. I assume we would not want to have different logic defined in WebRTC. So
totally great.
But maybe we should go back to JSEP and revisit that, though.
No.
or change it to a should.
I love this text. It's perfect
but I
as
think
is.
we
I
can
don't
look
want
out
to
in
change
the
anything.
but all right.
Okay, so it sounds like we have consensus to take this more or less as is. Correct? Okay.
Yes.
All right. Now we get into a block of various issues around Git contributing sources. So this first issue is that assuming an application will use the audio level member of RTP contributing source to drive an audio level UI, for example, showing a volume indication for each speaker in a call, the audio level is currently specified to be updated whenever an RTP packet is received, but there isn't any guarantee that that will be in sync with the audio that's being currently played out by the browser. So you could end up with audio level indications that are updated ahead of when the audio is actually heard. This seemed like a problem. I couldn't see any way that an application could get around this because there's no attribute that, for example, indicates the current delay between the contributing source timestamps and when the audio will be played out. So my suggestion is that somehow we change updated when packet is received to update at play out time. We may need to talk more to work out the definition of play out time, but that's the general concept. And in the PR, I just sort of wrote up an example of how this would look, where it says, you can see here a quote here, when the first audio frame contained in a packet is delivered to the receiver's media stream track for playouts, the objects are updated. So this is the thing that may need some wordsmithing. But what do people think about the general concept? Is this the right direction, or is there another solution?
This is Adam. I guess what you... go ahead, Colin.
No, you go ahead.
It seems like the use case you described seems very reasonable, and I think that's the one we should optimize for. I
was going to say, Colin, here that does seem like I agree with the problem. If we do something like this, I think we should also keep the old definition of what we had for this. So you sort of have because depending on how you're using statistics, you might want to understand what's happening on the wire or what's happening after your jitter buffer.
When you say keep the old definition, do you mean in get stats for the equivalent?
I guess in get like some way in stats of getting sort of at both of these to some degree.
Okay, well, yeah, in WebRTC stats, there's also, I forget if the PR has been merged yet, but there's a suggestion to have contributing source objects. So we could have the get stats version be updated as packets are received, and the one that on RTP receiver, which is expected to be used to actually, drive the UI and application logic, be synced with playout. That would seem reasonable to me.
Yep.
So we do have a need for a good story about knowing when what's the relationship between packet arrival time and playout time. But I think that's something that we need to look at in extensions. Not here.
So one comment. Hey, this is Janivar. Sorry if I missed this last time. I'm a bit concerned that this method is synchronous, and that would mean that I think an implementation would have to, if it's doing media on a separate thread, it would have to always send runnables to the main thread to update this information just in case someone were to call this method. And unlike, for instance, with stats is synchronous, but stats would have more leeway to only do this effort when the JS asks for it. Is that a concern? Has that been discussed?
I think there are ways of optimizing implementation such that you shouldn't have to queue something on the main thread for every packet received, for example, because you only need to update it if it's being called, if that makes sense.
Yeah, but if it's called and you need to give an answer immediately, you have to either have the information already there, or you have to synchronously fetch it, blocking main thread to do it. The only alternative to that would be to store this in some type of atomic that could be accessed from both threads safely, and so you don't have to send runnables back and forth, which is doable but more complex, especially when you have lots of CSRCs and so forth.
Yeah, I think the bottom line is that it is doable. It just how it's done is an implementation detail, but I don't see there being a significant barrier.
Well, when I say doable, I mean in the theoretical sense. It doesn't mean that it's easily doable. I'd have to think about whether or not it's a real major pain or not.
We have other things like on the ICE transport interface where the object may be, the underlying object may be updated on a different thread. So I don't think it's a new problem.
I guess what I don't like is that it seems like there would be some effort involved in making this available, even if it's, regardless of whether it's used or not, which seemed a bit expensive.
Even in the form before where it's updated as packet are received, wouldn't it have the same problem?
Yeah, and that's bad too.
Okay. Well, in that case, maybe there's a new issue to be discussed.
Because I guess we need to spec this. We need to queue a task to update the audio level every time. Because writing to that JavaScript attribute, I guess we need, even though no one is actually interested in it, we need to queue a task to update it.
Yeah. Anything that happens on a per packet basis that touches the main thread is a really bad thing.
I mean, I would expect it to behave that if you compare it to like a scroll event, it's more like that than that's how you would like to use it. I agree with Geneva there.
This has come up before where it's been a bit controversial to have things that are runtime observable and have state actually change on a single event loop. So you can like busy wait in JavaScript and listen for data and see changes. And that's true for timers, but for very little else. So I mean, have we considered making this an asynchronous method?
That hasn't come up yet. I assumed that it still would not be updated multiple times in a JS event loop. Maybe we're getting too into implementation details here, but the implementation we're currently considering for Chrome is to the first time it's accessed within an event loop, essentially like retrieve it using a mutex from the other thread and queue an event to like set a flag that will cause it to be updated the first time it's called in the next event loop cycle. So I don't think it's very hard to have an implementation that both is efficient and respects the JavaScript single thread illusion.
I mean, mutex or an atomic or something, those are the ways in which you'd be able to access it from both threads at the same time. And you're right, it's probably not very contended. The important thing is you'd have to, have a reference to this so you know where to get it from. So maybe it's not so much a big idea. I mean, Yanivar, you can chime in what you think. If we wrap it in a mutex or use an atomic with same difference, then we are safe. And the biggest thing is you make a point. I'm just trying to decide if it is something we really need to worry about.
Well, I think what
if
we're
we think
talking
about the
though,
usability
is
on
a potential new issue, right?
Could you repeat, Bernard?
It's not related to this one.
Could you repeat, Bernard? We didn't catch the first.
I'm asking whether we're talking about filing a new issue or about the outcome of this one.
We've been discussing something separate from the issue in this slide, sort of more general issue about the Git contributing source API.
Yeah, so I'm suggesting maybe people should file an issue on this new thing, and then we can talk about that. And
Anybody, you want to file an issue on that?
Okay.
And I think in this issue we should actually include some code, some JavaScript code on how we're supposed to use this. I think that would help.
Yes.
Okay, I can do that.
Well, that's yet another issue, separate from this.
So Taylor,
I think
this
it
is
fits
Dan.
in it. Yeah.
I have a different concern about this. My concern is close to what Harold said, which is that this is a bit of a slippery slope because once you put something into a media stream track, you don't really control when playout occurs, right? There can be other APIs that could delay the playout of a media stream track, and essentially this is, we are tying a little too closely together, the receipt of this information with when that information might be used, essentially. We might be able to get away with it this one time, but it feels to me a little bit like a hack that could give us trouble later on.
Yeah, I think I agree a little bit. I mean, we're assuming it's being played back, for instance. I mean, what if it's going straight to a recorder or something else?
By the way, I understand the use case. Let me say, I understand completely the use case and agree with the issue. I'm just not sure that that I'm comfortable with the solution direction.
So I wrote up a spec that deals with measuring the time spent for getting to playout, and that was for video, and that turned out to be Well, there are some complications in it. So I think it's not an easy fix. We also in stats have some variables that are intended for measuring the playout delay and whether or not audio and video are in sync. They are pull requests now. And again, the fact that the variables have gotten estimated in the names indicate that just figuring out what number to return isn't trivial. So I'm a bit afraid it could be more thornier than we thought.
It's hard to get exact numbers on any of this because parts of it aren't under your control. The actual hardware output drivers and so forth you don't control. You don't necessarily know the exact delay on. So all of these things are estimates.
So we can do certain estimates, and any stream has a consumer, and the consumer is still within the browser. So it might not be actively harmful.
That's true.
Just remember that one of our driving use cases for this too is displaying who the active speaker is, which, we can definitely, if our estimates or whatever they are, if they're within 20 milliseconds, that's really good, right?
As long as the application is able to, have an audio level UI that's within some bound of error, I think that's acceptable.
I find that if it's anywhere on the downside of the jitter buffer, it should be okay.
Yeah, basically that's the bottom line. That there needs to be some well-defined point in time post jitter buffer.
Yeah, totally agree.
Yep, seems good. So let's go on and hope the resulting query is smaller than what we have.
So what do I write down for the notes decided? Some people want it async, and we're okay with it being after the buffer, but
there will be a new issue on the
there'll be a new
stuff.
Yeah, there'll be a new issue for the async thing Jim's going to file. I think, am I correct that we're otherwise largely okay with this?
I think so.
Yep.
Can we say something about the old behavior will live on in stats? That was your suggestion, Colin.
Yes, though it sounded like that was already there and no change was being proposed. So perhaps it's barely worth noting. I don't know. Whatever people want.
Okay.
May I ask, sorry if this is a stupid question, but if we have it in stats as well, do we need both, especially since stats is already asynchronous?
Yes. Calling stats in order to display volume is
heavy.
Leaves the performance of stats under more pressure than it's comfortable.
Right.
I believe this question was asked when the API was first introduced.
Stats pulls in so many other things that making it high performance in order to satisfy the volume display thing doesn't sound like the right thing.
Makes sense. Thanks.
Okay, time to move on.
Okay,
Taylor?
this should be a little less controversial. The get contributing sources method returns objects representing both SSRCs and CSRCs, and it wasn't completely clear to me when the SSRC objects are currently updated. The spec currently says if the RTP packet contains no CSRCs, then the object corresponding to the SSRC is updated. So this seems to imply that it's only updated if there are no CSRCs. But some cases have come up where an application may want the CSRC information even if a packet contains CSRCs. So my proposal is just to say that the SSRC object is always updated. And since it already needs to be updated in some circumstances, I don't think this should add any complexity to the spec or implementation. So I don't see any reason not to do this.
The only trouble I have with the SSRC object is that I'm not sure how we identify it. I mean, if we have 4 entries in this table, what is the SSRC object?
Right.
That's a good point. Well, if you were going to map CSRCs to speakers in the UI, you would already need some out-of-band mechanism for associating CSRC identifiers with speakers. So seems out of scope for the API. But it certainly may be convenient to have an indication object in itself, whether it represents a CSRC or SSRC.
I was thinking of, I mean, I was thinking that we could do something real stupid and say the first object is the SSRC. But then I thought multicast, and then my head got weird. No, sorry, simulcast. Then my head weirded out.
Yeah, I guess the first question is whether people feel we should always update the SSRC object.
Let's answer that question first. There are a couple more issues that may be more related to that question.
Yeah. So I'm in favor of updating this SSRC object always.
Yeah, so am I.
Here, people being for it and no one against, so let's go with that.
All right, so moving on, I believe, to issues that don't have pull requests on the next slide.
So did we need to do anything more about this identifying the SSRC?
Yeah, I think that's still open, right?
This may be related to the issue on the current slide, 1101.
Okay.
For Mr. Note Taker here, can somebody summarize what I should write down?
The previous one, people are okay with there always being an SSRC object, so I guess we can merge the pull request.
Yeah.
Okay.
Yeah, the only question was how to differentiate that one from the CSRCs.
Which is what we may resolve on this slide. So this issue is that and a CSRC is a contributing source, but an SSRC is not. So the naming of get contributing sources is confusing if it also returns SSRCs, which are synchronization sources, not contributing sources. So I think the options are to either drop contributing from the name and just call the method get sources, and I guess change RTC RTP contributing source to just RTC RTP source, or add a separate get synchronization sources method that would only return the SSRC objects, or just decide that we're fine with things the way they are and document the discrepancy at least.
How much code would break if we change this?
Do we have an implementation
yet, so nothing should break.
I have one implementation, and we've implemented it.
Oh, okay.
But we only return the CSRCs.
Ah.
Okay.
So for architectural cleanliness and compatibility with existing implementation, I suppose we could have a get CSRCs call that returns the same kind of information. Get SSRCs, or whatever you want to call it.
that sounds good to me. So that was the second option there.
So
Any
second
other?
option good?
Sounds so.
Okay, we added a feature. Sorry about that.
Well,
Harald,
I'm sorry, go on.
Vivian, just a clarification question. You said you are going to add a second method, get synchronization sources. It will return the SSRCs. So what will the existing method return? Just the CSRCs?
Yes, one method would only return objects for CSRCs and one would only return them for SSRCs. So then the earlier question of how you tell which is which would not be a problem anymore.
Yeah, good.
Oh, wait, is this gonna, what happens if you call get synchronization sources on, say, a video receiver? Is it gonna give you some SSRCs but no audio levels, or?
Yes.
You define for, okay.
Yeah.
All right, I guess we can move on then.
Yes.
Okay, so I was going to just write a PR to change the type of send encodings to be a dictionary that only includes RID, with the assumption that the only use of send encodings that was intended was to affect the number of RIDs and their identifiers. But when I was doing this, I noticed that the simulcast example currently sets encodings with both RIDs and encoding parameters. And ignore the fact that encodings is not called send encodings, and it's scale down resolution by instead of scale resolution down by. I think there was just an example was written an earlier version of the spec. But clearly at some point the intention was that if you add a transceiver with these encoding parameters, it will both affect the result of the generated offer, and once an offer answer exchange is done, we'll start using these parameters. So it's sort of a combination of how add transceiver is currently spec'd and RTP sender set parameters. So next slide. The question is whether we want to keep things a current way where send encodings only is used to affect what RIDs get generated, or make it a combination of what it currently is and RTP sender set parameters. Would it be sort of an added convenience for the application, because otherwise they would need to do a full offer answer exchange and then get parameters, set parameters, even just for the the simple simulcast example on the previous slide.
Yeah, my recommendation would be to allow it to function as an early set parameters, but with the same restrictions. Like you shouldn't be able to write something that's only that's read only, I think. And of course, the RIDs would still be the only thing that influences the SDP, but you could kind of avoid another call that way.
And on the next slide is a list of members of RTP encoding parameters. So if we do go that direction, so another question is which of these an application is allowed to specify in send encodings. I guess the SSRC, for example, is I assume read only. So
right, and so is RTX and FEC because they only contain SSRCs.
would it make sense to say that all of the non-read-only parameters can be set? I guess I don't see any problem with that at the moment.
Yeah, but only the RID will influence the SDP.
Right.
So would the rule be, sorry.
Go ahead.
Or would the rule be that when you put it in send encodings, it's as if you had called set parameters immediately after set remote description gets these things flowing, or set local and set remote?
Yes, that's what I'm thinking. And currently there's a send encoding slot on RTP sender which isn't used anywhere. So if we did go this route, then we would just, I imagine, in steps for set remote description, say, if this completes the negotiation of a transceiver, then follow the steps for RTP sender set parameters with the contents of the send encoding slot, et cetera, et cetera.
Yeah, just as a question, would set parameters then modify the send encoding slot, or does it stay the same?
I think we can work that out in the PR, but
So let me just paraphrase what you're proposing here. Is this just becomes syntactic sugar effectively for a shortcut to do what you could do by calling the same thing with set encodings, and the things you can change are exactly the same set that you could currently change? Is that?
Yes.
Okay.
So it's not completely syntactic sugar because there is a disadvantage to having to call get parameters, set parameters again, and that a frame could leak out with the parameters that you don't want.
Right. Okay, that's a good point. I think that's a strong argument for this.
I mean, though, on that point, this doesn't completely solve that problem because you can only do this on the side that generated the offer.
Right.
Because one side will call add transceiver, and the other side will have the transceiver be created after it calls set remote description. Oh, though it can, never mind, it can still set the parameters before it sets its answer then, so maybe that's not an issue.
So is it totally clear what will happen if you try to set something you're not allowed to change?
Well, the same, I guess, is what happens in set parameters, right?
It would be odd to get an invalid modification error from add transceiver since there's nothing modified, but it would probably make sense to have some error as opposed to just failing silently or failing later in a set remote description. That would be even less intuitive.
I think we would need an error of some sort.
All right, so if I, for example, try to set the SSRC in add transceiver, that would throw an error of some sort.
Yeah.
All right, that makes sense.
Well, it wouldn't be an RTC error, right? It would be a...
No, it would probably just be a DOM exception.
Right.
And this is Jan Ivar. I don't think this is really a comment on, we don't implement add transceivers yet, and so we're talking about send encodings here. Just want to double check that this will be compatible with the simulcast implementation in Firefox that we have right now. It's possible. We do have add tracks, so you can call add track and then immediately set parameters before doing offer answer exchange. Is that compatible with everything we've talked about so far?
Maybe that's a separate question. I don't think set parameters is very well specified right now, but in previous discussions, I thought that we had talked about only being allowed to set the parameters after remote description has been applied, because that sort of negotiates the envelope of parameters.
Right.
But this isn't specified anywhere I can see currently, so.
I think we did add something, although I'd have to look at the spec to figure out what. But I think we did specify along the lines of what you just said.
Okay.
So then, if that's not allowed, would this new send encodings be a way of doing the same thing? Because unless I misunderstand here, this is during add transceiver, which is before offer answer exchange.
Right. Although it wouldn't let you do the equivalent of reordering codecs.
Sure. But you could set multiple RIDs and set up multiple scale resolution down by and stuff like that.
Right. Yeah. As on the example 2 slides ago. Right. So that would work if we went this direction.
All right. Thanks.
All right. So no opposition to this. All right. Sounds good. I can write PR.
Okay. So another question is, so say you call add transceiver, and how do you know how many simulcast streams you can send? Because you could, for example, create add a bunch of RIDs in or something, and you go over some internal limit. How do you know what that is? Yeah, so you could throw like an invalid parameters exception, or similarly, the promise could be rejected in transceiver.setParameters.sender.setParameters. And also, in existing implementations, simulcast is supported for some codecs, but not necessarily for all the video codecs. So the question is how the application figures out what can be done and what can't be done. So some of the things you might want to know would be, for a given codec, the maximum number of simulcast streams that can be sent. And if that was like 1, you'd know that simulcast is unsupported in a codec. There's also a question of whether in some implementations there's a limit to the aggregate simulcast streams that can be sent, as opposed to just the ones within a given codec. And so one idea we've kicked around for this is whether you need a max simulcast streams attribute in codec capability that tells you for a given codec what the max simulcast streams is. I think the default here would probably be 1 rather than 0 or something. So I guess the first question is whether people think this is an issue, and if so, whether the suggestion here makes any sense. Any opinions?
I mean, doesn't the maximum number you can send usually largely depend on the resolutions you're sending on each one of them, too?
Well, that may be part of the question. It could, I suppose, right?
Yeah. I'm just thinking about our implementations. This would be I mean, we know when you've asked for too many because it doesn't work. But it'd be surprisingly complicated for us beforehand to decide what number we would return here.
Yeah, the problem is, because in what we've been discussing, right, you call these things, there's no RTC error level of details, so you just basically get an error that basically says it didn't work. And in practice, we've been supporting these encoding parameters, right? A lot of things could go wrong. So it's not always easy to figure out exactly what you did that it didn't like.
Okay, so that seems like a really strong, regardless of what we do here, seems like a really good argument for improving the errors for these types of things, because I totally agree with you. It's a nightmare to figure out, why it barfed.
Right. I mean, the only thing, and I don't know if we're actually doing this, Colin, would be if you did get an RTC error and at least it referred to the SDP line that had a simulcast in it, that might give you a hint, but I don't think we're saying that right now.
Well, you can't do that before you generate the SDP, so.
Right, exactly. So yeah, in this particular case, the add transceiver, right, you don't even have SDP, so Yeah.
Yeah. So in a debug situation, you can just look at the message that comes back with the rejection notice. But in the runtime situation, that's the complex one.
Well, especially if it's something like what Cullen suggested, dependent on the resolutions or something, right? Or the aggregate number of simulcasts being sent for all codecs.
Yeah. If you can easily add another even lower resolution, but if you add a higher resolution, things blow up to kingdom come.
Yeah. So I was just trying to deal with a simple case here, like you asked for 4 simulcast streams and a given browser supports like 3 or 2 or something.
So I just read through our code, and I found that it basically has a mechanism when you're using software encoding where you give it a resolution and it tells you how many layers it can do.
Oh, okay.
Which it turns out is
not exposed. Not exposed in JavaScript, right?
Right. It's almost always 3, and it's not per codec. But when you use hardware encoding, that's a whole different story. So.
Yeah.
I mean, from experimentation with stuff too, I would guess that number right now isn't based on what's happening on other tabs. It's only what's happening in this origin.
Correct.
Wait, I don't really have a strong opinion on what we should do with this. I'm pretty sure that if we do add this, we're going to need to write it in a way that it is, at best it's not a guarantee that something will work. It's a hint. Maybe it's a guarantee of if you go over this number, it won't work, or something like that. But I think we still need, the most important thing will be to clean up the errors for when it doesn't work, regardless of this.
Yeah, but the problem right now is I'm not sure how we go about cleaning up the errors because we're just generating exceptions and promise rejections, not RTC errors at the moment.
Do you mean in the spec or in the implementation?
In the spec. Yeah.
Oh.
Yeah, we even in, there's.
So Yonivar, let's just say take 2 simple cases. One case is we had an error because you picked a resolution that was too large, and another error you picked too many simulcast streams. What would be your view on how we should return that type of error given the API we have?
I'm not sure. I'm still catching up on RTC error that we have it. So
okay.
There's nothing much to catch up on because it isn't referenced in many places. So.
Oh, is it?
We don't even have error. We didn't even have simple error events for anything like this. So.
Right.
I remember us talking a long time ago having some error when you couldn't sustain something any longer. I mean, for example, the chip got too hot and you had to go down in resolution or down in number of streams. Did that ever make it into the spec?
No.
So it
was just adjusted,
That would be the equivalent of overconstrained.
Yeah, sort of, and I was thinking about when you talked about runtime errors, Harald, it's sort of close to this.
Well, let me ask this question: Is there even a sentiment in the working group as to how to address this general concern? Because right now we don't even really have a mechanism for using RTC error here,
Bernard, I think I would agree with your statement. It's very difficult to debug this. It's not just a debug issue that only happens in development. It happens in real time on production because people have different machines with different capabilities and hardware and all the things that have been mentioned. So I think we should try and deal with this somehow or other so that we can get good information back.
Do you have an opinion on how that might be done?
No, not really. I mean, I guess
Could we?
Every one of the mechanisms we use has a way to do it. So.
Could we use RTC error and do something similar to the STP line number indication, but rather than returning STP line number, return the subset of the RTP parameters dictionary that was objectionable?
Mm-hmm.
That's
here's a question, Taylor. Like what? Because we don't have any. I guess you're saying like put that in the message or something. I'm just trying to think where it would even go.
Well, the promise would be rejected with an RTC error, right? And we could have a new field for on RTC error for whatever format we want this information.
Oh, okay.
In.
The promise of which method?
I guess that would, if it's a promise, it would be set parameters, right?
Yeah. I assume that's what we were talking about.
Yeah, that makes sense.
Okay.
Sorry, I'm on the sidetrack, but there's also RTC error event in here in the spec now, but it's also not referenced anywhere. Is that right?
Well, I think that's just confusion over RTC error.
Okay.
Yeah, there's a bunch of loose ends that have to be tied up with respect to that. Okay, so at least we have, assuming people agree with Taylor's general direction, we can try to explore that. All right.
Let's explore that.
Yep. So issue 1086. This is an input from, I think, a guy implementing WebRTC in WebKit, right, Adam? He would like to have the legacy APIs optional to implement in the spec. And that's the callback-based APIs rather than the promise-based ones. However, the Chrome counters say that the legacy APIs are used a lot. And basically my question, and I'm looking at Dom, perhaps mainly, is there any precedence on what to do? I mean, we got the input from Fulip that most specs have bits of APIs that aren't implemented everywhere without being a spec valuation.
I think we should, given that we call it the legacy API, we should make it optional explicitly. And that would solve this issue and make it clear that this is not something developers should rely on in the long term.
In the short term, this will decrease interoperability.
Yes, Janova, I would be in favor of this. Probably not a surprise, but I did notice that UNF did push a pull request to Adapter.js, the WebRTC polyfill for AdStream, which I thought was a good solution for dealing with a similar legacy type API. So I guess it's possible you could use Adapter.js that way.
I think that was proposed here as well. But what I hear people thinking is that we should mark it as optional. Okay. Let's minute that.
Right. Can you repeat the summary so I can jot it down in the notes properly?
Yes, for issue 1086, we should make the legacy APIs optional to implement. I mean, mark them as let in the spec.
Okay, thanks. Sorry, I missed it.
So just wanted to talk a little bit about DTLS failures. Today, the DTLS transport object has an on-state change event handler and a DTLS transport state of failed, so you know when the DTLS transport has failed, but there is no on-error event handler. And the question is, in particular, dealt with some issues relating to mismatched crypto suites. For example, a browser offers only ECDSA, but you have a peer that's a mobile app that's based on old and moldy code that only supports DTLS 1.0 with RSA certificates, so you can get a crypto suite negotiation failure. And so the question is there any way of figuring out that that just happened? Currently, there isn't. Now, there are a number of issues with security, and in the next slide, I have the text from WebSockets. And basically, it says you can't convey any failure information to scripts that would allow the script to distinguish any of the following situations. So really, any kind of failure, hostname can't be resolved, packets can't be routed, refused the connection, failed the TLS handshake, opening handshake, any of that. So you're not supposed to provide information that allow you to discern any of those. So the question is whether, and here's the rest of it, and this is where, again, they use the connection close code. That's really the same for any of those. Whether, with this same kind of logic, whether it's possible to give any information about the reason why DTLS failed. Or you just, look at the state and figure out that it happened but have no idea why. Any thoughts?
I mean, the one thing I'm sure of is I don't want to have to guess why things didn't work and what I might do about them, because these are all recoverable errors.
Yeah, that's the problem. This is a recoverable error, but right now, you can't recover it. You didn't know that it happened.
So will the recovery process be different for different errors?
Well, many of them are, there's a whole series of things which are not recoverable. The particular one I mentioned is. The other things that can happen, obviously, is, some kind of DTLS generic handshake failure, which is probably not recoverable.
So, Bernard, what is the reason why the WebSocket is not allowed to convey that information?
Well, I think the fear here in WebSockets, it's basically that you would leak security information for somebody trying to, write an automated attacker. I think that's the problem, right, Harold?
Yes.
And is that applicable in our case or not?
That we do permit connections to be set up to things like other hosts on the local network. And if the attacker is lying about what the IP addresses are, the defense we have is that people being attacked are not going to send the ICE back. So yes, there is a mountable attack, which means that if you have, we don't do DNS failures, so those don't count. But we can, if we tell the attacker the difference between there is no host and the host doesn't have a port, and the port is open but it's not replying correctly, that's food for an attacker.
Yeah, but it will allow you to write a network scanner.
But to even get to the DTLS handshake with WebRTC, you need to get ICE connected. So it seems like the attack vector is a lot smaller. You couldn't use the DTLS error to get information about the attackee's local network environment, because nothing on their local network is going to be an ICE server.
Well, I was going to say the same thing as Taylor, or how we require ICE consent. And if that doesn't fail, you get one static error, which is in this thing. This is all long past the point where consent's been granted. So I think all of these you're already past the point of worrying about those things.
Yeah, if that is true, and nothing in the error codes return, and you can never get this error without having ICE consent, then I think we can regard it as not dangerous.
Yeah, I agree.
Okay. Well, so my question is, should we consider, for example, adding, well, right now we don't even have an on-error event handler for the DTLS transport object. So the question is, should we consider adding RTC error detail, for example, for some of these things? Do people feel it's worthwhile to try to distinguish various types of DTLS errors?
I mean, if there is anything you can do about it.
Yeah, this one was one of the few that I think there was something you could do about it, the mismatched crypto suite.
Right. There's one other one that I'm not sure there's something you can do about it, but I still want to know about it anyway. And that is that basically there's been a man-in-the-middle attack and your fingerprints didn't match.
Oh, okay.
And
right.
No, there's not something you can do about it, but it certainly helps you in explaining when somebody phones you and complains that your product doesn't work. It helps you explain to them why it doesn't work.
Right. So, Colin, do you have are you saying you think that RTC errors should have errors for at least those conditions?
Yeah, I think so.
Okay.
I hadn't really thought about it before this call, but yes, I think so.
Okay. Is there any sentiment about? Well, we can figure out where the errors should be thrown from, but I'm going to move on for now.
So for the previous one, did someone volunteer to do a proposal in the form of a PR?
Well, I'll try to come up with something, since I'm handling a bunch of the other error things.
Thank you, Bernard. Okay, so moving on to media capture main. I mean, we've talked in the past about that iframe needs to be explicitly delegated the right to use camera and microphone, and the path we went on was to use this allow user media attribute, which is used, for example, in allow full screen and some other places. So that is what we got in the spec right now, but there is a new proposal to base this on the new feature policy specification and add individual attributes for camera, microphone, and even speakers. And I don't think we should deal with speakers here because that would be the audio output spec, to my understanding. But both of these methods seems to be not totally stable right now. I mean, the allow user media is referring to the what working group HTML spec, and there are some changes. And the other one is much newer, and it's also not crystal clear to me which one will prevail in the long run. I've created a PR to introduce the newly proposed method on individual allow for camera and microphone. I've got some feedback and will update it, but basically I want to hear on this call if there is any opinion or any views in the group on the way we should go here.
But to be clear, this PR is only about splitting allow user media into camera and microphone.
Yeah, but it's also starting to reference the feature policy spec and for the definition of feature and so on.
Okay.
And feature policy is a little more restrictive in terms of what the attribute means compared to the current allow full screen, allow payment request, allow user media.
So I have a question. What camera and microphone? The problem you get in here is when you start detailing these out is the list can grow because of variations on what you're referring to. For example, does camera include the possibility of screen capture or window capture or ... And what if there's a new type of capture? What about canvas capture? I don't know if that would really apply, but the point is that if you start getting that fine-grained, it's hard to, you run into the problem of you're tracking a moving target, as well as perhaps forgetting to specify the n many things you need to specify.
So I think that's by design, and the design can be criticized. Again, I think the feature policy spec is still early in its lifetime, but the idea is that by design, embedded content should get as little advanced features as possible, and as a result, you would want to grant access to these features explicitly and not implicitly. And so, yes, if you wanted to grant screen sharing access, you would have to add the right feature policies.
Well, and that's fine. Fine-graining permission is fine as far as I'm concerned, so long as you're dealing with a relatively stable list. So the question here is, camera and microphone is almost certainly not sufficiently stable.
So I think we're specifically talking about get user media as defined in media capture and streams, which only grants you access to camera and microphone. And
no, that's wrong. Because you can get screen capture from get user media.
No,
that's a different method.
Implementation.
Not in the spec.
In the spec, it's been moved to a separate method.
Fine,
but
whatever.
None of the browsers implemented.
You get permission to find out someone's location on the network.
Yes, that's a feature.
Yeah.
So the things that would be enumerated here are kind of finite, though. There would be the things that are hardware, like the things we give permission for. So it's camera, microphone, screen share, maybe audio capture of the system. But I can't think of a fifth one. Speakers, I guess.
Right. So I mean, if we're going to do this, we should make sure we have the full list, okay, and try to think what might occur in the future. Now, obviously, you can always add them, and if someone has written in a list and they didn't include some new thing that came out, then you don't get it, which is probably part of the reason for feature policy.
Right. It seems by design that you don't implicitly get permissions for things we haven't thought of yet.
The feature policy drive seems to be that anything that can be restricted should get its own feature. So I had a discussion at BlinkOn about whether feature policies should be get user media or it should be camera and microphone. And I started out thinking that the allow user media approach of treating everything as the same was good. And after having discussed it for a while, I changed my mind, because there are cases where it makes sense to give away the microphone and not the camera, or the other way around.
I'm okay with that, but like I said, we just need to make sure we have the right list.
Oh yes, and or rather, each spec that defines a new way to get media must add itself to the list.
Exactly, and my worry is the stability of this feature policy spec, that is not just abandoned 6 months from now. And
we've been through this ringer a couple of times already.
Yeah, I think it has interesting momentum, but it is, just in incubation. I think it started to get implementation in Chrome, but at least from my perspective, it sounds like something we should consider, but maybe not bring in the spec quite yet until we get clearer vision on where it's going.
I agree to that personally.
So it would be nice to have a spec that people could implement from that included it. But I don't know. Does that have to be the main spec, or could we make a 2-pager that said just this is how you feature restrict get user media?
I think we should start by writing that 2-pager and then figure out how to integrate it or publish it separately or whatever.
Yeah, then we just need a volunteer editor.
If I find time, I could look at the 2-pager.
Okay, the hero treads in.
So what should I jot down in the notes?
That the group is a bit hesitant to bring this into the spec because we don't know about the stability and of this new spec.
Yeah, so Stefan will write up a 2-pager that says that is a separate spec for doing it.
Yeah, I wouldn't go as far as calling it a spec, but just a couple of pages.
Yeah, it's so small. It will get plenty of review because it's so short.
Okay, seems that was the last one we will manage today.
Actually, yeah, I think we're probably out of time, but Janivar added another one.
I did, although the timing seems to be okay.
Can people stay a couple of more minutes? Okay.
All right. Okay. So the issue is in stats is you enumerate stats dictionaries by type, and for inbound RTP and outbound RTP, there's a Boolean in the dictionary itself that you have to check. So it's basically 4 types covered by 4 dictionaries covered by 2 types, and that's a pain because basically there's no way to enumerate these stream stats without checking the is remote. And worse, if you forget to check is remote, you might be reading the remote data and think it's the local data and vice versa. So also over time as the spec has grown, the dictionaries, they started out symmetric and now they're not symmetric even. So there are things that are different in whether it's the members that are present based on whether you're looking at the remote or the local one. In fact, the stats example in both WebRTC and the WebRTC stats spec actually fails to test for is remote. So something I noticed after this PR. So those have always been wrong and could be looking at RTCP data or the remote data instead of the local data. Instead, the PR introduces 2 new types, remote-inbound-RTP and remote-outbound-RTP. In order to, so they're basically more explicit definitions of the actual members you would see. And there's a lot of commonality that's been pushed into base classes. So I just bike shedded some names here that you can see in the slide. So basically, what I'm showing here is only the differences. So RTC inbound RTP stream stats would contain frames decoded. And the other benefit of mapping out the differences here is that we no longer need the amorphous cyclical sounding associate stats ID. We can now call it remote ID, and that would look up the remote outbound RTP stream stats in this case. And the document also reads a lot better, I think, in that it won't have a green comment like here, but the definition of remote stats in the spec follows this directly and says, instead of pointing to an amorphous RTC stats, it looks up. You can see the actual type that you're linking to, so that you can glean the structure directly from the WebIDL, which I think is nice. So that in fact, we used to have example number 1 was actually used to be a sort of explanatory diagram of this relationship, and I actually removed that in the PR because it seemed redundant now. So, and to go through the dictionaries, then the remote inbound RTP stream stats would then contain a local ID, which would be pointing back in the opposite direction as a remote ID, and would have round trip time, which is unique to, the RTCP gathered data. And for same thing, and they both inherit from the same common directory, the inherited dictionary RTC received RTP stream stats. So conversely, on the outbound RTC outbound RTP stream stats contain remote ID, target bitrate, frames encoded, and total encode time, which are the ones that I think are only on the sender side. And then RTC remote outbound stream stats would not have those, but would have everything else we're accustomed to, that for packet sent, stuff like that. And also the local ID pointer and the remote timestamp, which is not the RTC stats timestamp that's gathered locally, but the remote NTP timestamp that's unique to from the RTCP packet. And so those are all the changes. Thoughts?
So speaking as the guy who originally put in is remote, I like this one better than is remote, given that the amount of backwards compatibility problems we have seems to be small.
Great.
Plus one. Any objections?
Silence will be taken as consent.
I think people seem to like this one.
Yeah, this
Especially
is way better.
since current implementations don't do is remote. And then there's a real problem when they start implementing it. Current applications are going to break because they don't check for it.
Right. So there are two ways to get to the RTCP derived data, and that is to look for enumerate and using is remote, but the other one is to use the remote ID. At least Firefox encourages remote ID and actually implements remote ID. We haven't, which was the old name for associate stats ID. So it's actually backward compatibility plus for us to go back to remote ID.
Yeah. So you're the ones who have implemented is remote. So if you think the conversion burden is appropriate, then I don't think I should protest.
Great. No, I think this will be good for us.
Okay, thank you.
Okay, decision, let's go for it.
Yep. Yeah. So I guess we're at the end now. So thanks, Peter, for scribing.
Yeah.
And then special thanks to the guy who will have a boring 6 months, Harald, who has been pushing this work for almost 7 years now. We hope we will make some progress in your absence, but if you get too bored, you're welcome back much earlier than half a year from now.
I can imagine that happening.
If you're really lucky, we'll finish it all while you're gone. I hope.
That would be wonderful. That would be wonderful.
Well, thank
well,
you,
I have
Harold.
to invent something new. And thank you all for getting us this far.
Yep.
And good luck.
Yeah, we need that. Thank you, Harold.
Thanks a lot, Harold, and enjoy your time.
Okay.
Thanks.
Bye for now.
Bye-bye.
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 Bye. Bye.
Bye.
Interesting. I don't seem to be able to leave.
I